right, so the first thing we're going to do is open up the DATS-solo data acquisition software. So for today's demo, I'm only going to be capturing vibration data using the DATS-solo. I don't have the hardware that I've shown in that first option, which can capture both data or vibration data and GPS. All right, so once we open up the software, the first thing we want to do is select a folder where we're going to store the data recordings. And this will be a folder on your computer. This next settings button is for selecting a high-pass filter, but this is only associated to AC coupling for our sensors, but we're not going to use that, so we can ignore that. And next, we can select the sampling rate, and we're going to set it to 1000 Hertz. And then our acquisition, we're going to do continuous because we're going to be trying to sync up vibration along with GPS. And next, we're going to select our input configuration, and today we'll be using a single axis accelerometer, and here I can change a very descriptive name for it. And here you would select the accelerometer type, whether it be direct voltage or an IEPE. Here we can change the units. We'll be using a millivolt per G sensor. So you do also have to enable it, otherwise it will not record unless you select or enable each channel. And we can also add an additional description if we want to store that with the input. And here, this information will be in the calibration certificate. So I'm entering 9.94 millivolts per G. That's just what it happens to be for my specific accelerometer. And here, I'm not going to select AC coupled. And then there's some trigger modes. We're not going to deal with that today because we're going to measure or record continuously. And then once we're done, we can go ahead and save this setup. And that way, every time I do this test, the inputs and the sampling rate and the type of recording you want to do will all be saved, along with the graphs that we're going to look in the next screen. That'll all be saved here in a single configuration file. All right, so now we'll go to the next tab here, data for data capture. And so here you can see that we've enabled one of those channels, the truck bed. And so what we're going to do is drag and hold and release, and then we can select the graph type. This is going to be a time domain, so it's going to record a waveform over time. And then the next one, we're just going to drag and drop again, and we're going to select frequency. So now we can look at the frequency domain. I don't think I actually selected it, so here we go. Now we have the frequency domain. Okay, and then you can see that this red light indicates that the hardware is not connected, so we're going to go ahead and connect it now. And then the light turns green. All right, now if we go back to the top and hit this play button, it's going to actually arm the hardware, so it's preparing it to take a recording. And then once everything is stabilized, then we're ready to start recording, and we would just click on that red button to begin the recordings. One last thing I want to do is add a couple of options to our graph. One is to show the legend for each sensor, and then set up the graph for auto scaling. So if it's a low signal or high signal, we can get a good view on that. Okay, so here you can see I have a single axis accelerometer on the truck bed. I glued this to one of the boats, holding the bed to the frame. And then you can see the cabling going through the rear window. And I've got my computer and DATS-solo set up on the console. So basically, we're going to be using a GoPro today to take the video, and the GoPro can also collect GPS data, so I'm going to be collecting the video and the GPS data and using that to later merge with the vibration data. So you can see how I've got the setup here. I'm also using a battery inverter to power up the computer. The DATS-solo only needs a USB-C to power it. And so here I'm going to arm the DATS-solo and get ready to sync up my start for both the Solo and for the GoPro at the same time. So that you can see that the DATS-solo is armed and is ready to record. So I'm going to hit the record and then also the play button, or sorry, record button on the GoPro. And let's go collect some data. So in this first option, I'm going to be simulating that I went out and collected data using that P8012 hardware, where it will record both vibration and GPS data into a single file. And now we're in the GAV Replay software, and we're going to select our data source and then our GPS source, which will be the same file. And when we select this file, it has all the information in there. When we load it in, you'll see there's a drop down of all the different recordings. There's one for longitude, latitude, altitude, and then there's also going to be one for vibration. You can select which signal you want to look at either by using the drop down or by scrolling using these right and left arrow keys. We also have a couple options for looking at the GPS data. We can either look at it via the auto scale or via the center portion, which you'll get a sense of what that looks like here in a little bit. And then finally, we want to select the video file that we want to view. So in this case, this was recorded separately. And there is the ability to sync up the data and the video file. And we do that by adjusting the offset between the video and data file with those bars, and then we lock it in by turning on synchronized data. And now we hit the play button, and we can see the cursor move through the vibration data and sync to the map data and the video. So that process is pretty simple. You just record the data file and then bring it into the GAV Replay software, and it's ready to go. Now in the second option, we're going to have to merge the data between the GPS recording and the DATS-solo recording of the vibration data. And in my case, I used a GoPro to collect the GPS data along with the video file. So I'm going to use some software to extract the GPS data. You won't have to do this if you're using a different GPS recorder, which is what we talked about before. But just to give you an idea, I'm going to upload this GoPro file up to this website, and it does the extraction for free. They do have a paid version if you wanted to get a map overlay and some other options. But in my case, I just want to extract the GPS data, so I'm going to select that. And for the sampling, the highest I can go is 100 hertz. So if I can only do 100 hertz, that means I'm going to have to use the DATS analysis software to resample to get it to 1000 hertz, which is what the vibration data recording was. So it's doing its thing here. It's going to spit out a CSV file. And I'm going to open up this file. But before I do that, I'm going to actually copy the original file so I can preserve it. I'm going to copy a file and then put it in a same folder as the vibration data recording. So I have everything in one place, and then I'm going to manipulate the CSV file here. So before I bring it into the DATS software, I have to clean up this file a little bit, and you might have to do this with the GPS data that you collect using that other device. But here, all I really want are three parameters. I want the longitude, latitude, and altitude. So all these other signals I'm going to go ahead and remove. And I'm using this other software, modern CSV software, because it doesn't have any row limitation like Excel does. So in this case, if I have a very large file, I can manipulate it without any issue. So here I'm going to have two headers. I'm going to have the actual description, latitude, longitude, altitude, and then I have the units underneath that. So this is going to match the vibration data recording that I did with the DATS-solo software. So once I'm done here, I'm going to go ahead and save it. And now I'm going to open up the DATS analysis software, and then I'm going to use a worksheet to perform a few functions. So here at the bottom, you see files analysis. So I'm going to start with files. It's like an explorer. I'm going to go ahead and find the data file. Before I do that, I'm going to open up this worksheet. And this worksheet I set up beforehand. This is something that I would provide to you, but you can also build it from scratch. But this basically will go through the process of resampling the CSV file and then merging it together with the DATS-solo vibration recording. And after it's merged the file, I have in this worksheet to spit out two different files. One merged DAC file that we can bring into the GAV Replay software, but it's also going to spit out a combined file in CSV format so we can check to make sure that the sampling is correct. So once we're ready to go, we just select the input file name, and this will be the CSV file that we exported from the GPS or the GoPro GPS file. And so essentially you select that, and you do have to specify like number of headers, and we have 2 of them, so we have to change that there. We also have to tell DATS software what sampling rate this file is at before we resample it to the higher rate. So here we can select the resampling function, and here we set it to 1000 to match the original vibration data recording. And then the next step is to have the software prompt us to save the GPS data as a DAC file before we merge it with the vibration DAC file. So it's they're both in the same format. So there you can see that's the vibration data. And here we can specify what vibration file we want to merge the GPS data with. So you can see a waveform is already in there, but we want to make sure that we're selecting the right one. And so this is a worksheet that you can copy or use and reuse if you have multiple projects. So you set this up and then you just go in and change the source file. Another way to do this is to use a different function where you set up the source file individually each time you run the worksheet. So there are a couple different ways to do this. You can select whatever is best for you. I'm going to go ahead and delete this one. So you can see that's tied into the merge function, and then it spits out a couple different files. There's some more settings in here. We can go through this together later once you purchase the system. But that last function is to spit out both a CSV file, and then you can specify the output file name and location, and that'll be for the CSV file. And then there'll be a DAC file. So there'll be 2 different files. We're only doing the CSV file to sort of confirm the sampling rate, and I'll show you that here in a second. And the last thing I'm doing here is just setting up where I want to send that final DAC file that's merged. So now that we're done, we just hit the play button to run through this worksheet. And then the first step is to save the GPS data as a DAC file. And then it keeps running through the rest of the worksheet. And the last step is to save the merged file as a DAC file. That's what we're going to open up in the GAV Replay software. We also have a graph here that shows us that the merged file contains 4 different signals. And so this is an indication that all of the files have been merged successfully. And if we look at the vibration data, you can see that's just the single signal, and then the GPS data is the 3 signals. So yep, everything is working here. So before we jump into the GAV Replay software again, I just want to show you that CSV merged file. You can see that it contains 4 different signals. And if we scroll down to the bottom of the file, you can see that there's 391,000 samples. The vibration data is about 11 or 12 seconds shorter. That's the time it took between stopping the vibration recording and the camera recording. Here you can see that we also have that new DAC file with the merged data. I just want to make sure it's there. So when we go into the GAV Replay software, that's the file we're going to be opening up. Okay, so now we're in GAV Replay software, and you can see there's different types of layout configurations. You can stack them side by side, top to bottom. I like this window. And first thing we're going to load in is the vibration. Well, it's the same file, so we're going to open up the file and then select the signal, the vibration signal. So that's the merged DAC file. If I open it up, you can see from the drop down there's 4 signals. So what we want to look at here, we can look at any one, but I think in our case, we want to be looking at the vibration data. So that's there. And just look at the end of the signal. You can see that the GPS data is a little bit longer, about 11 or 12 seconds longer than the vibration data, as I mentioned before, because it took me that amount of time to stop the video after I stopped the vibration recorder. So there's a little bit of difference, but it doesn't matter in our case because we were pretty close to syncing up from the start. And so now we're going to open up the GPS data file, which is the exact same one. We load it into this other window. And so we're going to go into the GPS settings, and we have to associate the signals for latitude and longitude from that data file. And then we can select either auto scale or just the center portion of the route on the map. So once we load that in, you can see if I play the file, you can see the cursor move, and then you can also see the location on the map. And then now we want to open up the video file. And this is the GoPro file that I took, and load that into the third window. And so I know that there's about just under a second difference between starting the vibration recording and the video / GPS data. So I'm going to adjust this to about 0.7, 0.8, and then turn on sync. So now it's going to maintain that difference between the two files. So now if I play the file, you can see the cursor moving through the vibration data, and then you can see the location on the map, and then you can see the video file. The video is a little bit choppy in this video, the screen recording, because my computer couldn't handle all of these files at one time. So it's a little bit choppy. If I look at that file or play this in GAV Replay without doing a screen recording, it's a lot more smooth. But here you can see me attaching the GPS, or sorry, the GoPro to the mount on the bed. Eventually that camera is going to fall after going over some rough pavement. I didn't use the right mount, but for the majority of the video you can see the sensor there in the back of the truck. But typically with the GPS sensors and recordings, you want to make sure that the antenna or the GPS device has a clear signal to the sky. I read a lot about if there's gaps in the GPS data, you want to minimize that by making sure you have a clear sight to the sky. But yeah, here we go. And I am playing this back a little bit faster, just so you don't have to watch through 7 minutes of data, but you can see it running through the vibration data at the top, and you can see the map on the bottom section. And I have it set to auto scale, so you can see it starting to zoom out as it moves out of the frame. And if I use the center portion only, you can see that it's sort of sits in a center part of wherever the GPS signal is. But I'll go ahead and let you watch the rest of this video. But yeah, if you have any questions, let me know. Be happy to go through this with you in a web meeting or demo. There's a lot of details here, but it's really not as difficult as it may seem. I think the key thing is to start the vibration recording and the GPS recording as closely as possible. I didn't have to do a lot of data manipulation in CSV to get the timing set, but basically you would just delete the number of rows that you didn't need in order to sync up the data. But within 1 second of starting both devices, I didn't really have to worry about it too much. But anyway, I hope this video was useful, and yeah, let me know if you have any questions.